Now we're in interval section, and we have this easy problem, which is kind of locked actually for the free mode. So it's meeting rooms, and if we go to the LeetCode, it says subscribe to unlock. But I found an article here on Medium, and it says meeting rooms LeetCode number 920. I hope this is the same one, but let's learn about it. So, introduction. If you're looking for a quick walkthrough of an optimal solution to the LeetCode meeting rooms problem, it's a LeetCode premium article. So here's a LeetCode link to get around. You're in the right spot. So this is a LeetCode link, and it should open it up. So let's see what it is. This is a question in the Blind 75 LeetCode code challenge list, right? A group of questions put together by a tech lead at Facebook that's been touted as a great way to prep for interviews. Now, don't beat yourself up too much if you're here because it gave you a hard time. Everyone has a hard time with coding challenges sometimes, right? Let's get started. And over here what we have is this thing. And this is the question, which is right here. So understanding the problem, and then it kind of like gives you the explanation of how it would solve it. But what we're going to do is we're going to read it ourselves. So given an array of meeting time intervals consisting of start and end times, so we have start and end times. So we have S1, E1, S2, E2, all the way to like this. Basically, it's a list, and so it's like starting time and then the end time, and then we have another interval which is starting time and end time, right? Start 2 and end 2, start 1, start end 2, end 1, all the way to the end. So basically, it's start ith is less than end. Determine if a person could attend all meetings. Now, over here it says example. We have interval. We have this intervals. We have 0 start time and then end time, and then start time and then end time, and start time and end time. False. We can't we can't reach everywhere because 0 and 30 and 5 and 10 and 0 and 30 and 15 and 20 will conflict, right? Because when I'm starting this one, I have to end here, but when I'm in the 5th part of this one would automatically start, and when I'm in the 15th part, this would automatically start. So they will conflict. Now we have intervals 5 and 8 and 9 and 15. Well, this is true because the two times will not conflict, right? So basically this is a meeting rooms problem. We have to find that if all the time intervals are good, then we could actually attend every meeting. Okay? Could attend all meetings. And that's all exactly what we want to do. Now, over here you can see that we have a definition of interval, which is a public class interval. We have an int start, and I believe this is in Java, so we're going to change it to C++. Now, here we have definition of interval, which is a class interval, and we have a public section, and here we have start and end. And then we have interval constructor, we have a start and end, and this is the start and this is the end. Okay, so this is basically the constructor, and this is the solution where we have bool can attend meetings. Okay, and then we have vector interval and %intervals. Now this is basically being passed, so we're gonna send a vector of interval. Look, these are intervals. Basically each interval would be like this. Okay, so we're basically sending a list of intervals. So essentially what I'm thinking of here is that this is one interval. So this thing, okay, like this, okay, like this, start and end. And when we have a list of intervals, that means we have a group of intervals like this, okay? So that's intervals and subvector. Okay, write your code here to just check it out. So, I mean, we have this, solution. We're gonna write our code in here. Now, first of all, if we could actually sort the intervals based on the ascending order, like suppose the time frames are like this: 0, 30, 5, 10. If we could sort them in ascending order, it would be better because I don't want to randomize it. So if I could just sort it out like using a sort function, this is provided. So I say intervals dot begin, and then we have the intervals dot end. So basically this is a vector, and we could actually sort it out like like this, like this. Okay, so once we have that sorted out, we could actually go through the interval and see if the start time is before the end time. So I could just simply have I is equal to 0, or basically not 0. I have to check the second time, right? So I could say I is equal to 1, and I is less than the interval's size, because that's the vector. And then I simply increment it. I would use either prefix or postfix. I'm going to use prefix this time. So plus plus 1, and then in here what we're going to do is we're going to get the comparison here. What I'm saying is that if the interval sub I, which is the second, if that second time, okay, and then the 0th is the first one. So if this end time, I'm basically grabbing the end time. I'm saying if the end time, okay, of the 0th one, if that end time is smaller than this one, which is the previous one, I minus 1, like this, we could simply say return false. Okay? Else we would just, if this for loop goes correctly, we could just return true. That's the entire solution for this problem. If I get to run test and see, okay, WeChat scan code sign in. I don't need, I have to log in or something, but I don't want to log in. But I believe this is the solution. So let's just go and quickly check this out. So let's go here, explain the following solution, and tell if it's correct for the meeting rooms easy problem. Okay, so let's see what happens. The provided solution attempts to solve the meeting rooms easy problem, where you're given a list of input and returns. Basically what we're doing is given a list of meeting time intervals and need to determine whether a person can attend all the meetings without overlapping. Let's break down the solution. The function can attend meetings takes a vector of meeting time intervals as input and returns a boolean indicating whether a person could attend all meetings without overlapping. The intervals are sorted using sort intervals.begin, interval.end. This sorts the intervals based on the start times. Okay, so sorting the intervals is crucial for this problem because it helps in identifying any overlaps efficiently. Then after that, the function can iterate over the sorted intervals starting from the second interval, which is index 1, to the last interval. For each interval except the first one, it compares the start time of the current interval. So basically it compares the start time, not the end time, but the start time. So that's why it's like 0 over here. So it's essentially the start time, actually. Yeah, I kind of like mistakenly did it because first of all we look at this. It's a vector, right? So we first of all look at interval sub I. That's basically if you look at the list over here, if I could bring up the list, that basically means this portion. Okay, which is just 1 second. Okay, so over here it means this interval, which is right here. Okay, so sub 0, and this is sub 1. Okay, and this is sub 2. If I look at sub 1, this means this one. So okay, if I say intervals sub 1, sub 1, because the loop starts from 1, right? It starts from 1. So if I say sub 1, I capture this one, and if I say after that I put in sub 0, that means I start with this starting time. Okay, I look at the starting time, or maybe this one because I'm talking about sub 1, that's sub 0. So sub 1, sub I, sub 0 means this one, starting time 5. Now go back here, and it says with the end time, it compares the start time of the current interval with the end time of the previous interval. So if you look at the previous interval sub I minus 1, this goes backwards. So right now, currently we have I, which is the second one, and we look at I minus 1. This is the previous intervals n time. Previous intervals n time. So this one, 30. So what we do is we check 5 and 30. Okay, 5 is basically really small and 30 is really big, right? So I look back and say, if the start time of the current interval is less than the end time of the previous interval, right? Basically, that's what it means. If the start time of the previous interval, I mean the current interval, is less than the end time of the previous interval, it means there is an overlap, and thus the person cannot attend all meetings without overlapping. In this case, the function returns false. Exactly the same here. And if the loop completes without finding any overlaps, it means the person can attend all meetings without overlapping, and the function returns true. Now, regarding whether the solution is correct, the solution correctly identifies whether there are any overlaps in the meeting intervals by sorting them and then checking for overlapping intervals. If there's an overlap, it correctly returns false, indicating that the person cannot attend all meetings without overlapping. However, there's an issue with the provided code. The interval type is used, but it's not defined in the code snippet you provided. Assuming interval is defined elsewhere and represents a meeting time interval with start and end times, the solution seems correct with the meeting room's easy problem. So basically, it was just saying like, where's this interval type defined, and it really doesn't matter. It's it's defined somewhere, but our goal was to just complete this function, right? And we basically got the job done. Great job. It was a really good solution. We first of all sort it so that it's easy to sort based on the starting times. After that, we could compare and look at the second times start interval and compare if it's less than the end time of, the previous interval's end time. And essentially that's exactly what it's talking about here. So essentially that's what we do. We look at the starting times first interval, start interval, and we compare it with the previous interval's end time. I don't know why it's over here. Basically, it should have been, yeah. Exactly. I feel like I randomly, mistakenly add this, but this is the end time like this, right? So, we're good to go. It's a really correct solution. Ignore this. It should be 1 over here. I don't know why randomly, but this is the solution because I'm talking about the previous interval's end time, right? If the previous interval's end time is greater, then basically we return false. Else case we keep iterating until we return true. So this was the solution. Hope you liked it, right? And now we completed the meeting room's easy problem. Awesome.